Welcome to lecture 17 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. In this lecture, we will focus on interfaces and we will continue our discussion of abstract classes as well. Now, these interfaces should not be confused with the graphical user interfaces. These are Java interfaces. We will discuss interfaces. We'll also discuss comparison of the interfaces with the abstract classes. We'll look at extending interfaces and we'll see how it is different from extending classes. And we will also discuss final variables, final methods and final classes briefly. The relevant material for this lecture can be found in chapter 10 of the book Java How to Program Early Objects, Detail and Detail. And some of the relevant material can be found in the Java tutorial. The links are provided in the slide. Java interfaces are used in situations, for example, if an abstract class contains only abstract method declarations, it can be declared or implemented as an interface. So for example, we have a class, an abstract class that has no methods which need to be implemented in that class. So it only has abstract methods. Then that class can be declared as an interface. Interfaces offer a capability requiring that unrelated classes implement a set of common methods. So for example, when we use inheritance, in inheritance, subclasses inherit from a common superclass. The common superclass includes all of the common details that are inherited by the subclasses. So the subclasses need to have something in common so as to be a subclass of that same superclass. In our shape example, all of our subclasses were some kinds of shapes. Triangle was a shape, circle was a shape, and rectangle was a shape, and they had many things in common which were included in the superclass shape. But sometimes we might need the same functionality in two completely different classes. In that case, we cannot inherit a common class. For example, if we have an employee class and we have a furniture class, now the employee incurs some expense for an organization, that is in the form of salary, and the furniture incurs some expenditure for an organization, that is in the form of purchase price for that furniture. Now both of these classes are incurring some kind of an expense, but these are completely different classes. So if these two classes need the expenditure functionality or we need to calculate the expenditure of these two classes in the same class, what we can do is we can use the interface, because a furniture cannot inherit the employee class. Furniture is not an employee, but furniture is incurring some kind of an expense. We'll look at this in a future example in detail. Java interface defines a protocol of behavior that can be implemented. Same like the abstract class, which defined abstract methods that needed to be implemented by the subclasses. In the case of an interface, all of the methods are the abstract methods, and all of those methods need to be implemented by the classes that implement that interface. In abstract classes, we were able to implement methods as well as declare some of the methods as abstracts. We do not implement methods in interfaces. We only declare methods, and those methods are by default abstract. Defines a set of methods but does not implement them. There is no actual implementation in interfaces. Is never directly instantiated. We do not create an object of an interface. The interface specifies what operations a radio must permit users to perform, but does not specify how the operations are performed. And it can be true for any electronic gadget. We can only use the buttons, and those buttons perform some functions, but we do not know the underlying implementation of those buttons. So when we use a radio, we use some buttons to turn it on and off. We use some buttons to provide instructions to change, for example, the stations, but we are not provided with the implementation details of those buttons. And it can be true for any electronic object that we use. A Java interface describes a set of methods that can be called on an object, and we will see this in our discussion in the future slides. So to create an interface declaration begins with the keyword interface. Same as when we declare a class, we declare it using the keyword class. We declare an interface using the keyword interface, and it contains only constants and abstract methods. We need to remember that all interface members must be public. All the variables or the fields and all the methods of an interface are public. Interfaces must not specify any implementation details, such as concrete method declarations and instance variables. All methods declared in an interface are implicitly public abstract methods. So these are the points that we need to remember, that we cannot implement methods in our interfaces. We only need to declare those methods, and those methods will by default be public abstract methods. All fields are implicitly public, static, and final. These are the points that we need to remember about the interfaces. For example, interface, as I said, that we can take the example of the electronic gadgets. In this case, a VCR. If some of you remember what a VCR was, we can use the different buttons. We can press the buttons, and those buttons respond in the form of their functionality. So we can see the declaration of an interface. Public interface, the name of the interface. It is the same as the declaration of the classes, but the keyword class is replaced with the keyword interface. And we will save this file as vcr.java, same as when we save classes with the names of our classes. So public boolean load tab, this is the name of the button we need to, when we press the load tab button, some functionality will be performed. Now we do not need to implement that functionality over here in the interface. Similarly, an eject button is declared without any implementation. Now we can see that we do not include the abstract keyword with the methods. The reason for that is these methods are by default abstract. Public boolean play, public boolean pause, public boolean stop. So we only have the declarations of these methods, and the implementations of these methods will be provided in the classes that will implement these methods. Similarly, the fields in an interface are static, final. These are implicitly public, static, and final, as we can see here. In order to use an interface, a concrete class must specify that it implements the interface and must declare each method in the interface with specified signature. For example, we have an interface bounceable that has a variable and a method. Now the method of the interface is an abstract method. For a class to be able to use this interface, it needs to implement this interface using the implements keyword. Public class basketball implements bounceable allows the basketball class to implement the bounceable interface. Now what that means is the basketball class will need to implement the abstract method or any method that is there in the bounceable interface. As we can see over here, the implementation of the methods of the bounceable interface must be provided by the basketball class. And these two methods, public void hit wall, string wall name, the signature of these two methods needs to be the same. Now we do not have the public keyword over here because it is implicitly a public and an abstract method. Add the implements keyword and name of the interface to the end of your class declaration's first line. In inheritance, we were using the extends keyword to extend one class into another class. Here we are using the implements keyword to implement an interface in a class. A class that does not implement all the methods of the interface is an abstract class and must be declared as abstract. If you remember from our discussion of abstract classes, that a subclass that inherits an abstract class needs to implement the abstract method of its superclass. But if it does not, that subclass needs to be declared as abstract. Otherwise, we will get a compilation error. Same is true for interfaces. If a class implements an interface, that class needs to either implement all the methods of the interface or it needs to be declared as abstract class. Implementing an interface is like signing an agreement with the compiler that states, I will declare all the methods specified by the interface or I will declare my class abstract. So it cannot be said in the simpler words that whenever you implement an interface in a class, you must declare all the methods of that class and you must implement all the methods of that interface in your class. Otherwise, your class must be declared as an abstract class. Now, the difference here from the abstract classes is that in abstract classes, we did not need to implement all the methods of the abstract class. We only needed to implement the methods that were declared as abstract in the abstract class. And since we do not write the keyword abstract with the method declaration in the interface because it is implicitly an abstract method. Now interfaces are very frequently used in Java, especially when we use graphical user interfaces. In those situations, you will find loads of interfaces that are used in Java. One example is mouse listener interface. The listener interface for receiving interesting mouse events: press, release, click, enter, and exit on a component. So for example, you are creating a graphical user interface, a program with a graphical user interface. And as we know that any graphical user interface will require some interaction from the user. Now those interactions are provided using mouse or keyboard, and we need to have a response to those interactions or actions from the user. And the mouse actions, whether those are the mouse actions or the mouse events or the keyboard events. So Java allows us to use interfaces for all of those events, and the response to those events are then implemented in our specific programs. There is an interface, public interface mouse motion listener, an interface mouse listener. These interfaces need to, when we implement these interfaces in our graphical interfaces programs, we need to implement these methods. So whenever we create a graphical user interface, we should provide the implementation when a mouse is clicked, a mouse is entered, mouse is exited, mouse is pressed, and mouse is released. We should have a response for all of these methods. Similarly, we should have a response for when the mouse is dragged on our interface, in this case the graphical interface, or a mouse is moved on any component. A component can be a button, it can be a text box, it can be any component in our graphical user interface, and we should have some kind of a response for all of these events. The listener interface for receiving mouse motion events on a component. Any component, can be any component. So these are Java interfaces. In class diagram, an interface can be shown as with this symbol, with the interface written between these two symbols, and this is the name of our interface. So this is one mouse listener interface, this is a mouse motion listener interface, and for example we have some drawing area on our graphical user interface. Define methods for describing mouse events. An instance of a class that implements these interfaces can be registered such that its mouse listener and mouse motion listener methods will be called in response to mouse events. A mouse event can be clicking the mouse, a mouse event can be pressing the mouse or moving the mouse around our drawing area. For example, in this case we have a class that implements these two interfaces, and it is some graphical user interface on our screen, on our window. Class that implements mouse listener and mouse motion listener. A drawing area object can be notified. Now this is a class that implements these two interfaces. A drawing area object can be notified of a user's interaction with the mouse. So for example, when a user clicks on a component on our screen, there should be a response that is implemented in the drawing area class, because the drawing area class is implementing these mouse listener and mouse motion listener interfaces. We will see other interfaces when we study graphical user interfaces or graphical user GUI programming in our future classes. There is a relationship between a class and the interface that implements. Once a class implements an interface, it must provide an implementation of every method defined within the interface. Now this needs to be emphasized again, that there is a relationship between the interface and the class that implements that interface. and it must provide an implementation of every method defined within the interface. A class may implement some additional methods, but these extra methods aren't not accessible through this interface. It's the same like the superclasses. When we inherit the methods from a superclass, a subclass can have its own methods that are additional to the ones that have been extended from the superclass, and those subclass methods are not accessible through the objects of the superclass. Same is the true for class when it implements an interface. It must implement all the methods of the interface, and it can have its own additional methods. And of course those methods are not accessible from the interface. All objects of that class have an is a relationship with the interface type. As I said earlier, that there is an is a relationship between the class and the interface. And all objects of the class are guaranteed to provide the functionality described by the interface. By this we mean that whatever the methods are declared in the interface must be implemented by the classes that implement that interface, and consequently those implementations or the functionality will be accessed by the objects of those classes. This is true for all subclasses of the class as well, and we have seen this that whenever we extend a class, the objects of their subclass are able to access the functionality of the superclass. A class can implement many interfaces. Now this is where it is different from inheritance. In inheritance we said that we cannot inherit from multiple classes. Java allows single inheritance. Other languages, for example C++, allows us to inherit from multiple classes, but in Java we can only inherit from one class. But we can implement as many interfaces as we need. In Java, classes are less extendable than interfaces because a class can extend at most one other class. Java allows single inheritance. But there is a catch. Beware. Adding another method to an existing interface will break every current implementation of this interface. As we said that we need to implement every method that is declared in an interface. So for example, if we have implemented an interface in a class, and at a later stage we add a new method to that interface, now all of the classes that have implemented that interface will need to be changed to incorporate the implementation of that new method that has just been added to the interface. Now this will require a lot of extra effort and care to change all of the classes that are implementing that interface. What can alternatively be done is extension is preferred way to use new methods. Extension is preferred way to add new methods to an interface. Instead of directly adding a method to an interface, we can use extension, and we will see this in the upcoming examples.